Hello friends, welcome back to my channel. When we do good to others, the good things definitely comes back to us. When we think of Newton's laws of motion, the first law most of us in general remember is Newton's third law of motion. So most of the people, we focus on only that third law since it is very short, and we fail to remember Newton's first and second law, which is shorter than the third law. Even though statement is looking long, here the concept they convey is very short here in Newton's first and second law of motion. Okay, come, let's learn Newton's laws of motion in this video along with illustrations. Before moving to the video, I'd like to thank all my subscribers for your support. And if you are new to the channel, please do subscribe and press the bell icon so that you will get the notifications of all the video we upload here related to Gpstr exams, TET, Central TET, and for competitive exams also. Okay, let's move into the topic now. Newton's first law of motion. Already we have discussed about inertia in the previous video. Link is given in the description box. Please check it out. You will get an idea about inertia in an elaborated way. I just repeat here in a short form. Inertia of an object is of state of being in a particular state, either it is in state of rest or state of motion. Okay. So this Newton's first law is also called as law of inertia. Sometimes they may ask us to write the statement in the exams, but most of the cases they will ask for the examples, or they may ask to identify action or reactions in the given equations of Newton's third law, or the concepts related to this Newton's second law of momentum, those things. Okay, let's see the Newton's first law of motion now. If a body is in a state of rest, it will remain in state of rest, and if it is in a state of motion, it will remain moving in the same direction with the same velocity, same direction and same velocity, unless and until an external force is applied on it. It means an object is in a state of rest. It will be in a rest. If it is moving, it will be moving unless and until a force applied on it. For an object to be in a state of rest, if force is applied, it will start moving. It will be displaced. For an object which is already in motion, if you apply the force, it will stop. Right? Very easy law, Newton's first law. So there exists a kind of terms here like inertia and force related to this. These are the two key words for this. This state of being, whether it is in a rest or state of motion, is called as inertia. That is the inertia, the property of the object. Okay. So here, when the inertia of an object to be increased, the mass has to increase. When the mass of an object is increased, inertia also will increase. When we speak about this force, that says about the external cause which brings the change in the state of an object. Okay, that's all about Newton's first law of motion. And all these examples, that illustrations are given in the previous video where already we have discussed many examples. Please go to the description box or go to the playlist physics in our channel. You will get all the examples of inertia. Okay, let's move into Newton's second law of motion. The first thing we must remember that Newton's second law, F is equal to ma, something related with force. Okay, and there exists a word called momentum here, second law. It means F is equal to ma, but this a, acceleration, m is mass. This mass is related to momentum. Let's see how it is. According to Newton's second law of motion, the rate of change of momentum of the body, that is delta P we say. Momentum is represented in a letter P. Rate of change of momentum is delta. Whenever we write this delta, it means a small change. Even in mathematics, we use this delta symbol. So, rate of change of momentum of the body is directly proportional to force applied on it. We represent F is equal to delta P by delta T. We write like this. Up to here, this is over. Now, and the change in the momentum takes place in the direction in which the force applied. Suppose you are applying in this direction the force, the momentum also takes place in the same direction. Remember this. Hence, guess the quantity whether this is a scalar or vector momentum. Obviously, it's a vector. It possesses some particular direction. Cleared about Newton's second law of motion, and we represent this law F is equal to delta P by delta T, and which is equal to, we know P momentum is the product of mass and velocity is the definition for momentum. So P is equal to m into v. Substitute that here and divided by t. And we have already learnt about velocity of an object, acceleration of an object. Okay. So acceleration is nothing but velocity by time taken. So substitute this value of a here. V by t gives us a. And delta delta get cancels. Therefore, F is equal to m into a. This is Newton's second law, the formula for Newton's second law. Okay, the expression. SI unit of force is Newton. It is also expressed in the basic unit SI unit, kg meter per second square. And you can check it out, like in the previous video already we have solved how to take out this SI units from the basic units. You can also check it out. And here when we refer about mass, mass is the measure of quantity of a matter. Okay. And it is measured in kg, mass. Don't get confused with weight of an object. Okay. In the following classes we will take a separate class for difference between mass and weight. Okay. SI unit of momentum is kg meter per second. SI unit of force is kg meter per second square. Cleared? Let's see now how this Newton's second law we apply in our daily life. How this momentum is related. Okay. These are the examples of Newton's, few examples we have considered. Newton's second law. While catching a ball, the cricketer withdraws his hand. In this case of a cricketer, when he tries to catch the ball, he withdraws his hand, means he takes away his hand in the direction of the ball for few seconds, fraction of seconds, and then the ball comes to his hand. By doing that, he makes the time little more to be longer to reach. Suppose if he brings the hand here, the time taken may be t1. By withdrawing his hand for little more distance, he makes the time to be t2, so that in the time, extended time, the ball reaches the receiver's hand. And if time increases, the force decreases. We have learned just now in case of momentum. Actually, the force needed to stop the moving body. If you wanted to stop this body, you require two things. It depends on the product of mass and velocity, and it depends on time also. Okay. So this mass and the time in which he receives. So he delays the time. Hence the cricketer avoids the chances of injuries to his palm by withdrawing his hand along with the moving ball while catching it. Okay. I hope so it's clear. We can express this in the formula. The force is equal to change in momentum delta P divided by T. Okay, this change in momentum, how does this affect? Suppose let us consider this momentum to be 10 units. Okay, if the time taken is 2 seconds, we will get the answer as 5 Newton will be the force. Suppose you increase the time, okay, instead of same value 10 momentum, instead of 2 you take 5 ones are 5 twos are. So the force is decreased now. In the first case we got 5 Newton is the force applied on his hand. In second case, when the time is increased, only 2 Newton force is applied on his hand. So the force with which the ball hits this person is decreased, hence they will avoid the injury. Okay. In the exams, they may ask questions based on give reasons why it is so type of questions in the descriptive type. So if at all asked, you have to mainly focus on the time delayed, okay, related to the force applied on it. So that force is equal to momentum by time taken, rate of change of momentum. When you increase the time in which the object approaches the person, and automatically the force applied on it decreases. When time increases, force decreases. It's because of momentum. Also momentum will be playing a role, but because of time delayed. Okay, so here when the glass vessel falls on a hard floor, they break, but they do not break when they fall on a carpet. So suppose imagine hard floor, the glass falls on it exactly to touch the ground. If it takes 5 seconds and momentum is 10 again, so 10 by 5 gives us 2 will be the Newton. 2 Newton is the force applied. Suppose if it is of 10 seconds, momentum is 10. If this delays by 10 seconds, instead of falling on 5 seconds, it takes 10 seconds to fall, because there is a thick carpet, slowly it falls on it. It pushes, by pushing this downward, it takes little more extra time. So 10 by 10 gives us 1 only. So the force applied on the glass vessel is 1 Newton. Hence the force is decreased. Hence it will not break. Okay. And next example is, athletes often land on sand after taking a high jump. Okay. So when they high jump, when they jump and the person falls on the soft floor. So here also the same concept is applied here. The time delayed. Okay, therefore the time duration in which his feet comes to rest increases, and hence they may not get hurt. So these are the few illustrations of Newton's second law of motion. Okay, clear? Now let's move to Newton's third law of motion. So everybody knows this law. According to Newton's third law of motion, to every action there is always an equal and opposite reaction. And we cannot give an example how we would like to give like a normal way. Actually there is a method. There are some particular example which is suitable only we have to give. Okay, so few way telling, if someone slaps you on the right cheek, show them the left cheek also, you give them on the left cheek, so equal and opposite force. No, that's not the way actually. You see beautiful examples are given here. Pushing a wall. When you exert a force on the wall by pushing the palm of your hand against the wall, you experience a force exerted by the wall on your palm. Okay, so here two things we notice. When you push, this is action. The wall is exerting a force on your palm, that is reaction. Okay, they may give a statement and ask you to identify action and reaction in these cases. Okay. It's easy. A book on a table. When a book is placed on the tabletop, the book exerts a force downward equal to the weight of an object, weight of this book. Okay, it exactly applies here. The book exerts a force downward. Equally, the table also balances an equal force in the opposite direction, that is upward. Hence, we focus here two things. One is downward force by the book, other one is upward force by the table. So which is action? This is action, and here this is the reaction in this case of book on a table. So we can give many examples for Newton's third law of motion to identify action and reaction in the given statement. You see here, motion of the boat away from the shore. So if a person has to move to the sea from the shore, so here when he pushes the boat along with the oar, wants to move the boat away from the shore, so he pushes the shore by the bamboo or the oar. So that is action. So in return, shore also have a force on the boat, so boat moves forward, that is reaction. These two are similar only. Motion of the boat in water, even in the water. So in case of motion of boat in water, to move the boat ahead in water, if the person wants to move the boat in this direction, he is supposed to move, he or she, the water in the opposite direction. Okay, these are called as oars. So if they pushes the water backward with the help of oar, the boat moves in the opposite direction. Okay, so this is reaction, action, reaction in this case. Okay. In case of rocket motion, motion of the rocket. In the rocket, the fuel burnt inside the rocket in the lower part, and the burnt gas at high pressure and high temperature are expelled, means it comes out through the nozzle. So this part, this is called as nozzle. Thus the rocket exerts a force F on the gas expelled to them through the nozzle backward. So here they apply a force backward, experience a force here, and hence the outgoing gases, these gases will exert an equal and opposite reaction on the rocket upward. Hence the rocket moves in the forward direction. Firing a bullet from the gun. So in this case, identify the action and reaction. So when a man fires a bullet from the gun, the force F is exerted on the bullet, that is the action, and the coil recoils, that is the reaction in case of firing a bullet. Suppose we walk on the ground, motion of a man walking on the ground. So when the man pushes his feet against the ground backward by a force F, that is the action, the ground exerts an equal and opposite force on the feet of the person, that is called reaction. Okay, and same way catching a ball, while catching a ball, the ball exerts a force that on the palm, that is the action, on the hand, and the cricketer exerts an equal and opposite force on the ball, okay, to stop it, that is the reaction. Motion of a boat away from the shore while stepping down from it. Suppose you imagine there is a boat here, it's almost in the shore, and a person wants to leave the boat and he wants to get down from the boat. Okay, so as this man needs a force of action to step out of the boat, okay, for which he has to exert a force of action on the boat. So if he exert a force of action on the boat, and he will move the boat, he will come out of the boat, that is the reaction. Thus the boat tends to leave the shore due to the force of action. This man exerts the action towards this side, so the boat moves or leaves the boat, it moves away, that is the reaction. Okay, I hope so it's clear. There are a lot of things to be learnt in physics. Actually it gives a lot of explanations we can go on giving. Only for the examination point of view we are covering, which is important point, and still there are numericals we have to solve based on this concept of momentum and acceleration, all those concepts that we will catch up in the following classes. Okay, thank you for your support. Thank you for watching. If you like this video, please give a like, and if you are new to the channel, please subscribe our channel for more videos of Gpstr related videos of mathematics and physics along with science subjects also. Thank you.